Hello, everyone. Welcome to the Neo4j Online Meetup. A couple things before we get started. For maximum visibility of the video, we suggest that you set your resolution to 720 megapixel. You can do that by adjusting that at the bottom right of this video. Also, if you have any questions while watching live, you can actually ask in the chat window on the right-hand side. If you have questions afterwards, my colleague Mark is going to post a link for the community thread where you can actually ask the presenters directly questions about the project. So if you're not watching the live stream, you can do that afterwards. If you enjoyed the presentation and love our speakers, please give it a thumbs up on YouTube. And if you're interested in presenting in the future, you are also able to post about your project inside the community site, the Neo4j community site, which is the same link that Mark will be putting in as a thread in the projects category. So I think we can get started. My name is Corrine Wallach. I am the community manager for Neo4j, and I am here with my colleague, Mark Needham, developer relations engineer. Hello.
Hello.
Mark. Hi. We also, today we have with us Thomas Silkjær and Sony Green.
Hi. Hello.
And they will be presenting on building a graph of the XRP Ledger. Mark, do you wanna start us off, or would you like?
Cool. Yeah. So I guess what we normally do with guests on the online meetup is to sort of give a brief introduction to yourself and then explain how did you end up in this land of graphs and Neo4j to begin with. So I guess if we go in sort of reverse order, then we can lead into the talk. So maybe Sony, you can go. Maybe you can start and then just quickly introduce yourself.
Sure. So my name is Sony Green. I'm the director of business development for Kinaviz, and we developed GraphXR, which is a graph visualization and visual analytics tool. We had actually started off visualizing graphs a long time ago and built sort of our own graph database. When we discovered Neo4j, we thought this is way better. so that's really how we got connected.
Cool. Right. And I think you recently you published a blog post today on GraphXR. So I'll share that for everybody as well.
Great.
Cool.
Thank you.
Okay, and then Thomas, I guess we're over to you.
Yeah. Well. My path into Neo4j and graph databases is based on pure luck, I think. So I'm interested in day-to-day. I'm a graphic designer. I run a graphic design company, but I also love working with data. So when I started analyzing big data in blockchain, I found graph databases to be a unique way to do it. So I started looking into what's available on the market and ended up with Neo4j.
Cool. Okay. And was that like the first way you tried to model the data, or did you try some other approaches as well? Or?
Well, I've been working with BigQuery, a big data set. I've been trying some different graph database vendors, but eventually found it easiest, or the best tool set built around Neo4j. So that's how I ended here.
Cool. And I think the way we came across you was our colleague Michael had seen some of the blog posts you'd been working on, and I guess you'd been chatting a bit with him. So I'll share those posts in the chat as well. But I guess maybe Corrine, we can hand over to Thomas and can present to everybody.
Good.
Well, I'll try my best. So first I'll give a small introduction to the XRP Ledger. So XRP is a cryptocurrency, like Bitcoin. Most people know Bitcoin in some degree. The XRP Ledger is a decentralized ledger where you do money transactions with the currency that's called XRP. So every 4 seconds, more or less, a new ledger is closed with a lot of transactions that could be payment transactions or orders on a decentralized exchange. But basically, it is a financial network with accounts and money transactions. So I've been doing a lot of data analysis, big data analysis, initially using BigQuery on Google Cloud. And from there, I started to see if it was possible to do any visualizations, network visualizations. I've always been fascinated as a graphic designer by the beauty in visualizations. So initially, I did an export from BigQuery of a data set and loaded it into an application called Gephi for data visualization, and created a graph from that. I'll just quickly try to see if I can share my screen and show some of the visualizations I did here.
Yeah, cool. Can see.
Okay.
Yeah.
Right. So this visualization is based on an export from BigQuery to Gephi, and it displays all the accounts in this financial blockchain network as small dots. So every small little dot in here is an account, and all the edges are payments between the accounts. So for this experiment, I did a modularity or clustering algorithm to give it different colors, and I used a layout to make it look like this. And that's really my first step into graphs. So from working with visualizations of networking, I started considering how could this kind of technology be used to do the actual analysis of the data, because the algorithms that I could apply to this data set in Gephi was more sophisticated than what I could do in an SQL query on BigQuery. So I started looking into different graph database solutions and started learning that, and ended up with Neo4j, where I started by taking this exact same data set that I did this visualization on and imported it into the Neo4j database. So the first attempt was actually just moving data from BigQuery to the graph database, and I found it very simple to do so. So let me see how I can stop this screen share again. Here, yeah. So I started looking at what, from a data analysis point of view, what would I ideally use the data set for? Tracking payments between accounts, or applying algorithms. So I started modeling a schema for the graph database that would ideally simplify the data that is in the blockchain, because it's very confusing, maybe very difficult to understand everything that happens on the blockchain, on the ledger. So I tried to simplify it to a language that is more common. So instead of working with accounts and transactions, I'm working with wallets. That is a common term for an account on the ledger, and with payments. And decided actually to only include all the successful payments, because in a network on the ledger you can do transactions, make transactions that are unsuccessful because you try to send more funds than you own, for instance. Or so I only included the successful payments to a simple schema. Let me just quickly jump back to screen sharing. So I ended up with a very simple schema for the database. Only two different kinds of nodes. So I have a payment node and a wallet node, and a wallet can send a payment and a wallet can receive a payment. So it's a directional model like this. And a funny thing about the XRP Ledger is that if you want to create a new account, an existing account on the network has to do the activation. So I included a relation called has activated as well. So for each of the nodes, and of the relation, activation relation, I include some properties like the wallet has an address, an identifier. The activation happened on a date, so I'm using a date time stamp as a property, and the payments have a lot of different properties. It has an amount, it has a currency because you can send XRP, but you can also use the ledger to send different kinds of currencies. But from this model, I wanted to import data live from the ledger, so I didn't have to rely on an export from BigQuery. So I spoke with a good friend of mine, Wind, who runs a validator on the XRP network, and have the complete history from where it started to where it is now. And he sent me a huge database dump with the complete history. I think it was about 2 terabytes. So I started an initial import of this data into this schema from that SQL dump using Node.js. And from there, also creating a small Node.js tool to connect directly to the Node network and synchronize the database every 15 minutes, so it's always up to date. So right now the database is complete. It's hosted here on xrpgraph.com. It's complete and it's up to date, and contains all the accounts, all the wallets on the ledger, and all of the payments. So that's really how I started the adventure into graph databases, and a very quick introduction to the schema. Let me see. So there is a lot of different analysis you can do on a graph database like this, and one of the most common ways or most obvious things you want to do is like using, if you're familiar with blockchain already, using a block explorer to follow transactions and see how money travels between accounts. So using the Cypher query language, that's quite easy now. Here is an example of a query where I'm looking for a specific wallet. In this case, it's one of the wallets of a huge cryptocurrency exchange called Binance. I'm looking for that wallet and relations or payments it has sent to different wallets or recipients, and order them by date. So I get the newest 100 in this case. Let me just try to run that. So this is an example of a quick visualization of how money travels, and it's, yeah, this is just the 100 newest payments. So I haven't seen this before. The new payments happens all the time, but you can already see some clustering going on here. There's been a lot of payments from Binance to this account, and then you could start looking into what kind of relationship that is. So that's actually payments going from the exchange Binance to a different exchange called Coinbase. In this case, you also have one here that has 4 payments. Yeah, so that's from Binance to a different exchange called coinpayments.net. And here you have 2 payments going to Bitfinex. That's also a different exchange, and to some accounts that are somehow related to this. So it's a very interesting visual way to explore the relationship between accounts and the ledger. I've also been working with more statistical analysis and aggregation functions like sums and averages. But one of the good examples could be looking at the efficiency or history of an exchange. So in this case, I'm looking into the Bitstamp exchange, and I'm trying to summarize some statistics about it. So how many XRP has been sent from that exchange, and how much has it received, in how many payments, to how many different users in different places. So this is just an example of how you can use pretty simple query language to extract some statistics from the ledger. So it has sent, I think this is close to 9 billion, if I read it correctly. It has sent 9 billion, almost 10 billion, and it has received almost 11 billion XRP since it started. So some statistics that could be used for analyzing differences between exchanges on the network. Right. So there is a lot of other stuff that you can do. I've been working with a bit with algorithms as well, and doing page rank algorithms on subsets. So exporting a virtual database, a subset of all payments that has happened in a specific year, and looking at what kind of what wallet was the most central or important wallets that year. How useful it is, I don't know yet, because a page rank algorithm, of course, weighs in links higher than outgoing links, and that might not be the best option for ranking accounts, financial accounts. I don't know, but it's extremely powerful how quickly you can do it. I've also been looking at clustering through label propagation to see if I could find clusters that are somehow related or could zoom in an analysis on a subset of accounts. Yeah. Any questions yet, Mark?
Not so far. Only one comment. This is great.
Thank you.
We're going well so far. So what's been like the most? I guess one of the things that people sometimes find. I'm just wondering what's going on. Anyway, one of the questions people sometimes have when they first start using Neo4j is, well, they have two problems, which I guess you must have already approached. It's like, how do I handle data import, and how do I handle modeling? Is that like, are you going to get onto that in the talk, or is that something that we could discuss now?
I think we could discuss it. I didn't prepare anything directly on it.
Oh yeah, maybe we can just start just with a simple question then. So
yeah.
One thing people find interesting is how did you go about learning how you should model this data? Like, what was your approach to figuring that out?
I think from my work with Jeffy and visualization in Jeffy, you work with the same concepts of nodes and edges or nodes and relationships. So I had a pretty good idea of how I wanted it to work. I actually started off in a bad way, I think, because I wanted only one kind of node. I only wanted to have a wallet node, and then I wanted to have relations, a payment relation, and keep a lot of properties on the relation. But I found out that for indexing purposes and stuff like that, that was not the right way to go about it. So it also involved some kind of trial and error approach, and just spending some time and figuring out what worked.
Okay, so that would have been because the types of queries that you wanted to run against the data required you to start at you kind of wanted to start at a relationship or something.
Yeah,
related
exactly.
To a relationship. Oh, interesting.
Yeah.
Okay.
Yeah.
Yeah, that's quite a. I guess that's an interesting lesson, lesson or I suppose constraint of what the property graph model forces you to do. It's like it makes if you want to start a query from a certain place, it kind of guides you towards, okay, well, that needs to be a node, which is not necessarily intuitive for people when they start.
So
okay.
It definitely took some learning along the way, and a lot of trial and error.
Yeah. And so what was your approach? So did you pick a model and load that whole data dump that you mentioned at the start, or did you pick like a subset, or what was your?
I started with a subset. So from BigQuery, I made some queries to export the data in the shape that I wanted it. So basically in nodes and relations, in comma separated CSV files. And I started loading them, the CSV files directly using the tools available in Neo4j.
So is that using like the load CSV?
Yeah, exactly.
Approach?
Yeah.
Okay.
Yeah.
But presumably that only works up to a certain size, and then you're waiting a long time.
Yeah, well, then I had to do a lot of batching or trying to increase the commit size, and I can't remember all the terms for that, but it took some time to get my head around that as well. But eventually, I do know a lot of JavaScript already. I've worked with Node.js quite a bit, so I was happy to find a driver for Bolt in the package manager and npm. So I could write a CSV parser in Node and just commit it in bigger transactions using that.
Yeah, so we have a question from Yu Lee on the chat. It says asking, you said you have 2 terabytes worth of data with live streaming. And I guess the question is, did you load all of that using this load CSV approach, or did you have some?
Yeah, well, so I didn't load all of it because the 2 terabytes of data includes all transactions on Ledger, and not all transactions are payments. So there are different kinds of transactions that happens on the Ledger, especially in when you. The Ledger also includes an exchange where you put bits like a stock exchange, a forex exchange, where you place orders and buy orders and sell orders. So there are a lot of those transactions that are not included in the final graph database. Also a lot of unsuccessful transactions that didn't go through that I filtered out. And then I was also cautious about how much data I included in the final set. So in every single transaction, there is a lot of hashes, signatures, a lot of cryptographic terms and information that I didn't find necessary for this data set. So in total, I think the database is about 50 gigabytes now in Neo4j. But I'm pretty sure that it also stores it in a more convenient and better way than in an SQLite database.
Okay, and so I guess it's effectively just the payment subgraph of XRP.
Yeah.
Which summarize. Oh, cool. Okay. So did you ever use the Neo4j import tool as part of any of your process, or did you do all of it like just using load CSV approach?
All of it via Node.js. Yeah.
Oh, cool. Okay.
Yeah. So yeah.
So I guess some of the people watching may have seen. I guess it would have been about 18 months or so ago. Greg Young did a presentation talking about like how he built a graph of Bitcoin. I don't know whether you've seen that talk, but I guess you probably do know the. Could you like give like a high level contrast between these two?
I would love to. I would love to. I didn't. I was referred to it when I spoke with Michael Hunger a bit after I did mine, but I haven't really looked into it, so it's difficult for me to compare it. But I think that you can do a lot of the same kinds of analysis on it. So I think probably it depends on how you arrange your data, because I wanted to do it simple, because I think you can sometimes overcomplicate your data model. So I'm happy that I only have to relate to 2 different kinds of nodes and 3 different kinds of relations. And even though it's very simple, it's extremely powerful, because you can do a lot of interesting analysis from that alone.
Cool. Okay. And I guess if people want to read more about your process of how you built the model and how you got to where it is now, I've shared the blog post at the top of the chat.
Perfect.
So maybe now would be maybe it would be an interesting point at which we can hand over to Sony for a little bit and have a look at how we visualize the data. Does that seem like a good plan?
Sounds great.
Okay, cool. So Karine, can we give the power to Sony?
I will give him the power. Sony, you officially have the power now.
All right. So I actually want to start out by stepping outside the realm of XRP briefly and looking at another cryptocurrency, Bitcoin. This is looking at some of the sort of general techniques that can be applied to investigating any cryptocurrency or blockchain. Let's see. Oops. So, and back up here for a second. No, this is a investigation we conducted using Shodan. If anyone's familiar with that, it crawls the internet looking for unsecured servers. And what we found with Shodan is, we selected a subset of 1,000 unsecured servers, or using passwords that were just password. So this is those 1,000 nodes servers in Graph XR. We then looked at where those servers were in the world using the geospatial locations of the IPs. And then from there, connecting the IPs to the internet service providers. So we saw many smaller service providers, but a few larger providers that most of the IPs connected to. So some familiar names: AWS, Microsoft Azure, Linode. So this is where you're wondering what this has to do with cryptocurrency. So we work with another company called Hunchly. This is an open source intelligence tool that's used for forensics investigation, but has a lot of applications. A really cool tool. But we were told about a link to look for on these servers that would signify which ones were ransomware, and out of these 1,000, 1,100, 928 of them were still online. So we have the geolocation, and we have this message that we were looking for from these hackers, and then we were able to pull in the Bitcoin ID from this ransomware message. So it turns out that of these servers that were hacked, there are actually just 3 Bitcoin wallets that they were directing people to direct funds to. So this is, in the realm of cryptocurrency investigation, these would definitely be wallets or accounts that you would want to look into more closely. And this is, so yeah, you can see which of the IPs were hit by each of these accounts, and here's the message: all your Elasticsearch data have been backed up, and telling you where.
Sorry. Are you trying to share your screen? I think you might be.
Wow. Yeah, that would probably be a good start.
Green arrow on the left-hand side if you wave your mouse over it.
Yeah.
We're like, we can imagine, and I think that most of us have a good imagination. And you're so descriptive. It's helpful.
Paint a picture for you, and telepathically share with you.
Hey, I mean, words can describe a lot.
Now, while you're doing that, Carl Turacek asks us, do you have a public sandbox with this data? So I think actually Thomas and Michael Hunger have actually got one of these created. So if you look on the top of this live chat, you can see there's a couple of blog posts, and I think it's actually linked to in there. But I'll see if I can find the direct link as well. I think Thomas tweeted it a few weeks ago.
So yeah,
XRPgraph.com.
Cool. XRPgraph.com.
It's updated every 15 minutes, so it's complete data set.
What's the read-only login for people on there?
It should say XRP.
Oh yeah, XRP. Great, cool. All right, it's on the chat.
Complicated login.
Query the
Very
XRP Graph
secret.
live.
Look at us not sharing visuals and making secret passwords.
Yeah.
All right,
So,
we have the screen sharing. Great.
Perhaps perhaps it would be interesting to see what I was looking at while talking at you for the past few minutes. So as I was saying, and so this data set we do not have a sandbox of. The XRP stuff I'll jump into in a second. But again, we have our vulnerable IPs revealed by Shodan, the location of those IPs, the ISPs hosting them, seeing all of them unfiltered, and then trimming that down to the big players. Again, recognizable names, pulling in or identifying which ones have been ransomware with the help of Hunchly, pulling the messages sent to those ransomware servers, and then pulling the Bitcoin IDs from those messages. This reveals the three accounts that were the people were being told to direct their funds to. These are the connections between those accounts and the locations or the IPs they hit. And this is the message, including the Bitcoin address, telling them send 0.05 Bitcoins to this address. So that's what you guys are supposed to see in the past few minutes. So now I'll actually jump over to Graph XR, which is our tool that we were using to conduct that investigation. And this is with the XRP data set. You can see we just enter the host and the standard credentials from Neo4j, and so now this is the Graph XR environment. So I'm gonna start off by doing a cipher query to pull just the first 1,000 nodes from Thomas's XRP data set. And so we've got, like we talked about before, we've got wallets and payments, so the purple nodes. So right off the bat, I can look at, for instance, the properties of these. I can see, all right, we've got amount, the username. I want to look at currencies and see there's actually a lot of different currencies represented in these transactions. I'm actually going to cheat a little and show a function that's not in the current Graph XR, but is in. I can actually a pie chart to see what is the distribution of different currencies. You can see XRP is the largest percent, followed closely by US dollars. But then we've got a whole bunch of other ones as well. And you can see they're highlighted when I select them in the pie chart. So over here, I can go back to my label view and select all of the payments. I'm just going to tag these as all currencies. And then from there, I want to separate out the XRP payments, and I'll tag them as well and say XRP. So now I have two tags showing XRP and all the rest. And I'm actually going to get rid of all the rest because we have the numerical amount of these transactions, but we don't actually have the value because we're not doing the exchange rate, between dollars and yen and so forth, euros. So just comparing XRP to XRP is the most useful frame of reference. I'll delete these. And now I'm going to show another sneak peek here with pulling up this bar chart. I can see most of these transactions are relatively small. We've got some big ones, but they represent a very small subset. So I'm actually going to highlight those. You can see they're all in this cluster over here. So I'm just going to delete this one and focus on the wallets over here. So I've got a wallet that's activated a bunch of different accounts and made payments to a bunch of different accounts, but there's a lot of payments going back and forth, or really going forth, I should say, from this wallet to this wallet. And I can see the color coding of the edges. So red is sent, yellow is received. So now I'm curious to learn more about this particular wallet, and I can expand. I could pull in just the sent or received activity, but I want to see everything that's going on with this wallet. So I'm actually going to pull in 2,000 nodes here. You can see we've got wallets being created by this account and payments as well. And so I can start to do timeline filtering and see, all right, is there any particular flow from one to the other? And it looks like there's a steep drop off after a certain point. So I want to learn a bit more about this cluster over here. I'm going to again pull in 2,000 nodes here, it's going to pull in less than 2,000, but this way I know I'm getting pretty much everything. And so we see two other nodes here that are getting a lot of transactions. Actually, I should say one we're seeing a lot sent to, and one we're seeing a lot sent from. So this was kind of cool. When I expand these, I see a very different composition in the activity. So this one over here is like our previous ones. It's a mixture of outgoing payments and wallets created by this account. And I should say, when I talk about wallets created by the accounts, in XRP, and Thomas, correct me if I'm leaving anything out here, but to create an account, you have to create it from an existing account.
Yeah, correct.
Yeah. And so over here, you see we have an account that has no payment activity. It's just been used to create a whole bunch of other accounts. And then again, I can go back and look at the, over time, the activity. And by setting a fixed duration, I can actually scrub through and see, when all of this happened, and see that with my interesting node down here, the transactions happen later on. And Thomas, you were saying this particular cluster represents, it was a particular XRP program,
so
right?
actually the data set is also enhanced with publicly available information about some of the wallets, like exchange names. So if you can grab that inner wallet in that cluster, you should be able to see that a property for it.
So, oh yeah.
So you can see it's called the WCG XRP Giveaway Computing for Good, and actually in I think it was end of 2013, Rebel who had a collaboration with IBM, I think it was World Community Grid, WCG, to reward using your computing hours for good. And those rewards were redeemable for the XRP cryptocurrency. So I think what happened from that wallet is that the people who redeemed their WCG rewards had wallets activated. And in XRP, the first payment that happens to a wallet activates it. So for each of the activations, you'll also find a hash where you can find the actual payment from, and you'll see that it's of various sizes. Some were activated with a few thousand, some with tens of thousands XRP.
So that's, yeah. And I should mention too, we're at Kinvis not. We're kind of new to the realm of XRP. We actually learned about it from Thomas, seeing an analysis that he conducted in Graph XR, and he's been educating us in the ways of XRP since then. And so it's been really interesting to learn about. And this, finding this particular event is really cool. I'm just going to make a note of this. Computing for good. Then that creates a note node over here. And you might have seen I turned off all of the child nodes here. We have this leaf trimming that allows you to basically hide anything that has only a single relationship associated with it. So these are, within GraphXR, some of the tools that we use to conduct analysis. Being able to do the leaf trimming, I can grab a node and trace neighbors, jump from it to each degree of proximity. Or I can also look at the same thing from a tree view and the hierarchy that's established that way. So now, what does all this mean? I don't actually know in some cases, this is just really sort of like with the computing for good example, just looking to see what jumps out from a pattern recognition standpoint, and that's really one of the things that we wanted to do with GraphXR was to create a way for people to easily investigate something without having to have a great deal of a priori knowledge, to be able to do code-free investigation and to sort of bridge the gap in a way between the data teams and technical users, and then business users, people like me who are coming in less from the technical perspective and more just wanting to see what they can find. So yes, that's what we've done with XRP so far. And I actually, I also want to just give another sneak preview, not really connected to XRP, but this is, Mark, you'd mentioned that we have a blog post coming out today, and we're actually going to be announcing a new feature that we're very excited about, which is that you can now add GraphXR as a graph app within the Neo4j browser. So if or the desktop app. So if I just go to Neo4j desktop and add HTTPS. And yes, I trust this graph app. You can trust me. Maybe not to share my screen, but and now if I've got my GraphXR here, and I can actually start my database. Take a second. Two. And then launch directly into GraphXR. Well, that's,
yeah. I guess
you get the picture.
You get the idea, at least if the database is taking a while to spin up. Always the Google Meeting taking up all the memory of your machine on these things.
Yeah.
Cool. So the questions on the chat have descended into discussion and praise for APOC, the APOC library. I don't know if you have anything to add to that conversation if you've ever used it, but yeah, that's where we've gone over there. With just some questions around how you'd go about loading source data that was in JSON files rather than CSV, and then in relational databases, and so that's where we've been. That's what's been happening on the chat.
All right.
So I guess maybe what we can, given we're sort of approaching towards the end of the hour, maybe Thomas, what would be interesting is maybe we can do sort of like a summary of like what would be the next sort of areas where you think it would be either you're going to look into or something that somebody else might be interested in looking into. Perhaps I think you mentioned it sometime, and I know you've been working with Michael on running Neo4j's graph algorithms package on top of this data. So maybe you can start from there, and then obviously feel free to point out any other
absolutely
area. Cool.
So when you have a big data set of financial data, you can of course try to figure out how money are moved. What is money spent on? So you can do a lot of interesting things trying to classify the different accounts on the ledger, depending on the information you have available about them, of course, but also the activity. But some of one of the areas that I find very interesting is how you can use the data set for investigating criminal finances, money laundering schemes, scams, and things like that. As Sony also mentioned, they did a research on payments for ransomware. So especially now, I think, where we see more and more cases in the media of kidnappings and stuff like that, where the people behind require a ransom in cryptocurrencies, then this is actually a tool that can be used in an active investigation. I've done a little bit on that part myself, not in ransom cases, but in scam cases where people have been frauded, trying to trace the money back to exchanges where it has been cashed out, trying to figure out can we do that, and how do we work with law enforcement agencies to get insight from the exchanges about the people behind it. So cryptocurrencies are regulated in some degree. There is a lot of talk going around that cryptocurrencies is an unregulated world, but in most countries, if there is an exchange, if you run an exchange business, especially if you trade euros or dollars for cryptocurrencies, they have to follow the anti-money laundering laws and require know your customer information, passports and stuff like that from their users. So if we can track or trace money going to these exchanges from a ransom case or from a scam case, well, then there is a chance that it could be used to actually find the person behind or the people behind. So I think some of what I will find interesting in the future for this is looking into what kind of algorithms can you run on the data set, either the complete data set or just on parts of it, to find clusters that somehow have an indication that they could be a part of a fraud ring, or the activity that they send unusually many small payments, or some different patterns that fit different schemes. I think that's very interesting, and yeah. So what I've been doing for now is only page rank algorithms and label propagation clustering algorithms, and I've not had a lot of luck in using that data for anything. But it's a part of learning what kind of parameters you can get from doing it. So you get some clusters, and you can look into how are these wallets related. So an example Sony gave, you could see the clusters immediately. You could see the huge computing for good giveaway thing that would probably be a cluster using an algorithm as well. Yeah.
And I'd add to that, as Thomas has been talking about the ability to do this tracing of ransomware and potential fraud activity. And what's really great about cryptocurrency is that you can see this activity, and then in our work with law enforcement, there's the potential to sort of enrich that activity, like we saw with the IP information. There's other relevant information out there that you can connect and start to see sort of the picture that goes beyond just what's going on with the transactions. And so it's a really interesting data source.
Yeah, I think it'd be really interesting for doing some of that financial, like, fraud detection type work, because those data sets, they tend to be like completely closed off. Each keeps their one to themselves. So if you want to like make a demo of, hey, here's how you can use my tool to do some sort of financial fraud detection, you're like, what do I do? Just generate the data? So actually, this is quite a nice one where you're like, actually, there's a real data set. I haven't like had to go and make my own one up.
Yeah. Well, it's very interesting. Yeah, I think I would like to add one thing about Sony's presentation from GraphXR. I think it's very useful to have that third axis to. Well, that's how I've been using it. Basically, I've been starting all my investigations and research just in the Neo4j browser, and it's perfect until you reach a certain amount of nodes. Then it gets heavy. So in GraphXR, you almost don't hit any limits. And then you have the third axis in 3D, of course, where you can distribute, like he showed the filtering of over time. You could also distribute the nodes over time in a third axis. So you get somehow some kind of extra visual navigation tool. So I find that very useful.
Yeah, thank you. Yeah, that's I probably should have mentioned before, but yeah, one of the advantages to doing in 3D is that you're able to squeeze a lot more information on screen and interact with it in a way that things would get very busy and very hard to differentiate with a traditional 2D graph layout.
Yeah, and as a graphic designer and very visual oriented person myself, it really helps sometimes to get a visual on the data, because you get some sense of, you see the clusters immediately, you see the centralities immediately without doing the algorithms. But of course, from another point of view, algorithms that can do the same are amazing, because you can start using that for automated processes or alerts or stuff like that. Yeah.
Cool. So I guess we're pretty much nearly at the end of the hour. So maybe we hand back to you, Karine, to finish us up.
Okay. Well, that was amazing. We got a lot of really good responses too in the chat. I think everybody really enjoyed it. That was very, very impressive. Really cool stuff, and would love to learn more. So if you guys have any more information, feel free to add it on that thread. We'll also post a link for this video in the thread too. So I think that pretty much wraps it up. Like I said, if anybody watching, if you like the video and you think they did a great job on their presentation and their project, please give it a thumbs up. And feel free to chat with them. You can go to the community site, community.neo4j.com, and you can find both of them there. And Mark and I were also there too. And feel free to comment in the thread. And we hope to see you guys next week. Thank you guys so much. Really, it was awesome.
Yeah, thank you for having us.
Yeah.
Bye.
Bye.